Hello everyone, welcome to lesson 4 of Pre-Algebra. So in this lesson, we're going to conclude the properties of arithmetic operations. We're going to briefly summarize what we have learned in the previous 3 lessons and enrich the topic on arithmetic properties along with problem-solving techniques. So in the second half of this lesson, we're going to solve a handful of challenging problems together and demonstrate how to use all of these methodologies combined to help us solve the problem. Okay, so let's begin. So first, a quick review of the order of operations. So everyone should know this by heart now, that order of operations is we always evaluate the expressions inside the parentheses first. Okay, and then the second is from left to right, we're going to evaluate the multiplications and divisions. The next in line is from left to right. We're going to do the additions and subtractions. So we discussed the arithmetic property of addition in our first lecture. Let's do a quick recap on these, and we're going to pay a little more attention to subtractions. So subtraction can generate negative number. That happens when you have a smaller number minus a bigger number. So for example, if I have 5 minus 8, okay, and what would that be? Let's illustrate this on the number line. So here's my number line. On the number line, we always have an origin, which is the 0 mark. Okay. Positive number is to the right of 0 mark, and negative number are to the left of the 0 mark. So let's put down some markings. So here's our 1, and this is 2, 3, 4, 5, 6, and so on and so forth. Okay. Now, on this side, left side of the 0 mark, we're also going to put down some markings. This is also one step to the left, and that will be minus 1, minus 2, minus 3, minus 4, and so on and so forth. Okay. So in 5 minus 8 here, okay, we're going to start with 5. So at the origin, we're going to do 5 steps to the right of the origin. So we're going to start right here. This is our 5. Now, minus 8 means that we are going to travel toward the left because it's minus. And by how many steps? 8 steps. So starting at 5, we're going to travel toward the left. 1 step, 2 step, 3 step, 4 step, 5 step, 6 step, 7 step, and 8 step. Okay, so we landed here. Okay, so our final answer is minus 3. So this minus 3 here can be read as minus 3 or negative 3. So earlier we talked about subtraction is not commutative. Here we're going to see how commutative property can be extended to subtraction using negative number. So the key here is to treat subtraction as plus a negative number. So a minus b plus c, we're going to treat this minus b as plus a negative b. Okay, so it becomes a plus negative b plus c. Then in this expression, since the operation here are both plus, then we can use the commutative property of addition. And we can change the order of the terms in any ways we wish. So a minus b plus c can become a plus c plus negative b, which is minus b, or it can be, for example, c plus negative b plus a. So plus negative b is essentially minus b. So let's see an example. 144 minus 166 plus 23. So we're going to first work this out using simply order of operation and evaluate it from left to right. Okay, so 144 minus 166 plus 23. The first two terms gives me negative 22 plus 23, and the answer is 1. Okay. Now we're going to try to solve this using commutative property of addition with the help of a negative number. So 144 minus 166 plus 23 becomes 144 minus 166 is plus negative 166 plus 23. Okay. Now, since both operations here are plus, we can use commutative property of addition and switch the order of these two terms. So it becomes 144 plus 23 plus a negative 166. Okay. So this gives me 167. Now plus negative 166 is the same as minus 166. And the answer is 1. So the result is same on both sides. So a review from our previous lecture, we talked about in an expression, if a negative sign is in front of the parentheses, when we try to remove the parentheses, we change the sign of each term inside. Okay? So a minus b plus c parentheses is equal to a minus b minus c without the parentheses. Okay? So a minus parentheses b minus c becomes a minus b plus c. So we're going to take a look at two different examples. The only difference between these two expressions here are the left one has a addition inside the parentheses and the right one has a subtraction inside the parentheses. We're going to solve them by removing the parentheses first and then evaluate the expression from left to right. So this becomes 5,678. Removing the parentheses gives us minus 678 minus 133. So the sign of each term inside the parentheses is reversed. This becomes 5,000 minus 133, which gives us 4,867. Now for this one on the right, we have 5,678. Removing the parentheses gives us minus 678 plus 133. This is also 5,000 and then plus 133, which gives us 5,133. We also talked about earlier that when we want to group terms together and insert a parentheses, if the place we're inserting has a negative sign in front of it, then change the sign of each term inside after grouping. So in these two expressions here, if we're to insert a parentheses to group B and C together, the first one becomes A plus B minus C. Since it's a plus sign in front of the parentheses, the terms inside remains as is. In the second expression, it becomes A minus parentheses B minus C, where the terms inside the signs are all reversed. So let's take a look at two examples. So similarly, we're going to look at two examples. The only difference between these two expressions are the signs in front of 789 and 89. So we're going to group 789, 89 together and then evaluate the parentheses and follow the order of operation. So let's take a look at the left side first. It becomes 1,234 plus parentheses 789 minus 89. So because it's a plus sign in front of the parentheses, the signs inside the term stays the same. So it becomes 1,234 plus 700, which gives 1,934. Now let's take a look at the one on the right. So we're going to group 789 and 89 together. So it becomes 1,234 minus parentheses 789 minus 89. Since it's a minus sign in front of the parentheses, so the signs for the terms, they change. It becomes 1,234 minus 700, and the final answer is 534. So a quick review on our previous arithmetic properties of multiplications. So again, earlier we said division is not commutative or associative. But the key here is if we change divided by a number to multiplied by its reciprocal, then we can extend the usage of commutative and associative property of multiplications. So in here, if we have a times b divided by c, it's the equivalent of a times b times 1 over c. Then we can use commutative property to change the order of the terms in any way we wish. So similarly, parentheses a times b divided by c is equivalent of parentheses a times b times 1 over c. Okay, now we can use associative properties to combine any two terms together, and then the result will still be the same. So for distributive properties, we have parentheses a plus b parentheses divided by c. This is the equivalent of parentheses a plus b times 1 over c, which is equal to a times 1 over c plus b times 1 over c. So these three can be combined and hybrid together in solving a problem. And we're going to try to adopt them in the upcoming challenging problems, and you will see how they're used together. Now, so be careful here that distributive properties cannot be applied directly to division. If we have a divided by parentheses b plus c, okay, this is the equivalent of a times the reciprocal of b plus c, which is 1 over b plus c. But it is not the equivalent of a times 1 over b plus a times 1 over c. So let's take a look at a few review examples. In this first one, we're going to use commutative property. And we're going to do that by removing this division and turning to multiplication. So let's say we use 48 times 5 divided by 3. Okay, so this becomes 48 times 5 times 1 over 3. Now it's all multiplication. We're going to use commutative property by switching the order of these two terms. So it becomes 48 times 1 over 3 times 5. And this is 16 times 5, which the answer is 80. Now in our second example problem, we're going to try remove the division and then turn it into a multiplication and use distributive property to solve problems. So let's take the example parentheses 6 minus 9 plus 3 and then divided by 3. Okay, so the first step is to remove this division. This becomes 6 minus 9 plus 3 times 1 over 3. Now we can use distributive property and distribute 1 over 3 into each of the term inside the parentheses. So this becomes 6 times 1 over 3 minus 9 times 1 over 3 plus 3 times 1 over 3. 6 times 1 over 3 is 2 minus 9 times 1 over 3 is 3 plus 3 times 1 over 3 is 1. So this becomes minus 1 plus 1, which the final answer is 0. So in this third example, a divided by b divided by c, we're going to group b and c together by inserting a parentheses around them. Okay, because it's a division in front of the parentheses, then the signs for the terms inside will change. So let's take a look at an example. 96 divided by 2 divided by 3. So in this one, if we're to group 2 and 3 together, it becomes 96 divided by parentheses 2 times 3. Okay, so that gives 96 divided by 6, and that will give you 16. Now let's take a look at our fourth and last example. A divided by parentheses B divided by C. If we're to ungroup B and C by taking off the parentheses, because it's a division in front of the parentheses, if we were to remove the parentheses, then after removal, the terms for each inside needs to change. So let's take a look at an example. If we have 24 divided by 3 divided by 2, okay? So if we're to take off the parentheses, it becomes 24 divided by 3 times 2. So this gives us 8 times 2, which the answer is 16. So we have reviewed the arithmetic properties and looked at their extension to subtractions and division. Next, let's walk through a couple of challenging problems together by using hybrid combinations of all of them. So our first challenge problem, simplify this expression. Now take a look. In order to simplify it, we have to combine the like terms together. So the A in this here needs to be combined with the A in this here. And so is the B and then the C's. So to combine the terms, we have to first drop all the parentheses. So this here is called a nested parentheses. The square bracket is no different than the rounded parentheses that's inside. Okay. It's just the indicator that this is the outer layer of the parentheses. Now to evaluate nested parentheses, the order of operation is the innermost layer of parentheses is always evaluated first, and then we gradually work outwards. Okay. So let's first remove the parentheses. I'm going to write directly below it. This becomes square bracket A minus, to drop this inner parentheses first, it becomes B plus C, okay, close bracket. And then minus bracket, we're going to drop this parentheses inside, which simply becomes A minus B minus C, okay. Now we're left with only one level of parentheses. So we're going to drop these also. And this becomes A minus B plus C. Now to drop this one, since it's a minus sign in front, the signs for the terms inside will change. It becomes minus A plus B plus C. So next we're going to use commutative properties and move the like terms together. So before we do that, we're going to remove the minus signs by doing plus and negative of the number. So this becomes A plus minus B plus C plus negative A and plus B plus C. Okay. Now we can move things around since it's an expression of addition. This becomes A plus negative A, and then we're going to move the B's together, which becomes B plus negative B, and then we're going to put the C's together. So next, we're going to use associative properties of addition, and we're going to group these two together, which A plus negative A is A minus A, which is a 0. And then we're going to group these together. B plus negative B is also 0. And then we left with 2C's. Okay, so the final answer is 2C. Let's look at the second challenge problem. 1 over 2 divided by 1 over 2 3 times. So when we have problems like that, we're going to first attempt to convert the division into a multiplication. Now, divided by a number is the same as multiplying its reciprocal. So we have 1/2 times the reciprocal of 1/2 is 2. Okay, same for the third term. Multiply by reciprocal of 1/2 is 2. And then multiply by reciprocal of 1/2 is 2. So this whole thing is the equivalent of 1/2 times 2 times 2 times 2. Okay. So this becomes 1 times 2 times 2. And the answer is 4. Let's look at our third challenge problem. Find the sum of the digits in the product of 94 nines multiplied by 94 fours. Now these two are very large number, and they can appear a little intimidating to work with. But that's okay. Let's look at this number, 94 nines. That is 1 away from 1 followed by 94 zeros. And we said earlier that we like to work with numbers with trailing zeros because they usually help simplify the problem-solving process. So let's explore in that direction and see what we can come up with. So we're going to replace this 94 nines with 1 followed by 94 zeros minus 1. Okay, so here is 94 zeros. And then multiplied by 94 fours. So this is 94 fours. Okay, so next looks like we can use distributive property and distribute this 94 fours into each of the term inside the parentheses. So we have 94 fours multiplied by 1 followed by 94 zeros. So what that is essentially 94 fours followed by 94 zeros. So we're going to write it down, 94 fours followed by 94 zeros. So here is 94 fours followed by 94 zeros. Okay, and then minus 1 times the number is the number itself. So this is simply 94 fours. Okay, so we're one step away from reaching the product. Now, if you look at this subtraction here, we have 94 fours aligned with 94 zeros. But to have a bunch of zeros minus a bunch of 4, we have to borrow 1 from the last 4 that's right here. Okay, so that would make these 94 fours become 93 fours and then a 3. Okay, so what we're going to have is a bunch of 4s and a 3. So this here is now 93 fours. And the 3 is 1 borrowed to do the subtraction with the bunch of 4s. Okay, so now we have 1 followed by 94 zeros minus 94 fours. That will essentially gives us a bunch of 5s followed by a 6. And this bunch of 5 is 93 5s. Okay. So if it's not immediately obvious to you how this 93 5 came about, that's okay. Let's take some smaller numbers and then let's see if we can find the pattern there. So instead of 94 zeros and 94 fours, let's take 2 zeros and 2 fours. So we have 1 borrowed from the previous digit followed by 2 zeros minus 2 fours. Okay. So that will give us 1 5 and a 1 6. Now let's say we have 3 zeros minus this 3 fours here. That will give us 2 5 and a 6. Okay, so let's come back here. Now we have 1 followed by 94 zeros and minus 94 fours. So that will give us 93 5s and a 6. Okay, so this is the final product. Now the question is asking for the sum of digits in the product. So we have to add all of these up. Okay, so let me write it on the side here. So we have 4 plus 4 plus 4, so on and so forth, 93 of them. So if you add all of these together, that's essentially 93 times 4. Then we have the digits 3. And then we add up 93 fives. So 93 times 5. And then we have the last 6 here. So this expression will give me the sum of the digits. Now let's move this 93 times 5 next to 93 times 4. So this gives me 93 times 4 plus 93 times 5. And then we have plus 3 and plus 6. Okay. So 93 here is common in both terms. So we're going to factor it out. That becomes 93 times parentheses. What's left is a 4 plus a 5 plus 3 plus 6. Okay. So this essentially is 93 times 9 plus 6 plus 3 is 9. So we have a 93 times 9 plus another 9. So this is 94 nines. Okay. And then if you solve that, the product is 684. The final answer is 846. So let's look at this challenge problem. Given that 37,037 times 6 is equal to this number, find the product of 37,037 times 27. So let's first explore the relationship of 27 and 6. And why do we want to do that? That's because we already know what 37,037 times 6 is equal to. So if we can find the relationship, that might help us to solve the problem. So let's take a look. We have 37,037 times 27. Okay. So now 27, we're going to find the relationship of it with 6. 27 is 6 times 4 plus 3. Okay. So you take a look here. 3 is also related to 6. 3 is 1/2 of 6. So this becomes 37,037 times 6 times 4 plus 6 times 1/2. So let's take a look at inside the parentheses. 6 is common to both terms. So that means we can factor it out. Okay. So to factor out outside of the parentheses, we have copy down 37,037 times 6 times, we're factoring it outside of the parentheses, and what's left inside the parentheses is a 4 plus a 1/2. Okay. Now take a look. So you see here, voila, we know the answer to this because it's given. So that's 222, 222 times 4 plus 1/2. Okay. Now you probably see that we can use distributive properties to compute the rest of this problem. So this term times 4 gives us 888, 888, plus distributing this with 1/2, half of it is 111, 111. And if you add these two together, the final answer is 999, 999. Let's look at our next challenge problem. We have 6 nines multiplied by 6 9. So if you recall, this problem has somewhat of a similarity from an earlier problem we did, where we had 94 nines multiplied by 94 fours. So you can pause the video and try to attempt this problem yourself first. So here we have 6 nines, and this number is 1 away from 1 followed by 6 zeros. So let's go ahead and replace that, because we said we like to work with numbers that has trailing zeros. So we have 1 million minus 1 multiplied by 6 nines. Next, we're going to use distributive property to expand this expression. So we're going to take this 6 9 and multiply it into each term inside the parentheses. And 6 9 multiplied by 1 million is essentially 6 9 followed by 6 zeros. So we have 6 9 followed by 6 zeros minus 1 times this number is a number itself. So we have 6 nines. Now again, we have a very large number minus a relatively less large number. Now if you align the digits of these 6 nines with this large number, you will have 6 zeros aligned with 6 nines, and it's trying to do a subtraction. So that means we need to borrow 1 from this last 9, and this will make this 9 an 8. So what we have is we have 5 nines followed by an 8, and this 8 is resulting of borrowing 1 out of this 9. Then we have 1 followed by 6 zeros minus 6 nines, and that will essentially give us 5 zeros ending with a 1. So this is our final product. Let's look at this challenge problem. We have negative 39 plus negative 37 plus negative 35, so on and so forth, all the way to negative 1. So in this problem, let's first try to take out the negatives first. So we can rewrite negative 31 as negative 1 times 39. So this becomes negative 1 times 39. And similarly, for the next term, we have negative 1 times 37, which is negative 37, plus negative 1 times 35, plus so on and so forth, plus negative 1 is negative 1 times 1. Okay, you will see the reason why we write it this way. So here you can see that negative 1 is in each term, so it's common. So that means we can factor it out. To factor it out, we have negative 1 multiplied by 39 plus 37 plus 35 plus so on and so forth plus 1. And this 1 is this 1 that was left in here. Okay. So now let's take a look. We want to know the sum of this term. So let's first copy down the negative 1 and put it on the side. So you can probably see a pattern that this is 39 plus 1 is 40. And the next pair is 37 plus 3, which is also 40, and so on and so forth. So what we have is we have 39 plus 1 that makes a pair. And how many pairs there are? So if these are consecutive numbers, that is 39, 38, 37, we have 20 pairs. But since these are odd number, and so they're every other number, so we have half of the 20. So that gives us 20 over 2. Okay? Now let's evaluate this. So this becomes negative 1 times 40 times 20 over 2 is 10. So the final answer to this is minus 400. Let's look at our last challenge problem. We have A and B are two different numbers selected from 1 to 40 inclusive. Now the word inclusive means that 1 and 40 are included in the set of numbers that we can use. So sometimes you will see the word exclusive. that means that 1 and 40 are not included in the set of numbers that we can use. They're being excluded. So in here, it's inclusive. So find the largest value of a times b divided by parentheses a minus b. So if you look at this problem, it's basically a division problem. So we want to find the largest quotient. Okay. So what a and b is going to be that gives us the largest quotient? So to make the largest quotient, the divisor must be smallest possible. So that means a minus b must be as small as possible. Okay. So the smallest, we know that they cannot be 0 because 0 is not divisible. So the next smallest is 1. So we know that a minus b would be equal to 1. Okay. Now to make the largest quotient possible, then the dividend must be as large as possible. So that means a times b has to be as large as possible. So of course, we pick the largest number that's given to us, which is 40. So let's let a equal to 40. Okay. Now by the condition we found earlier, that a minus b is 1. So b is 1 away from a. So that makes b 39. Okay. So we have 40 minus 39 is 1. Okay, so a minus b is 1. Now we have a and b, we can substitute back into this expression, and then we will find our largest value. So this becomes 40 times 39 divided by 40 minus 39. Okay. So this essentially is 40 times 39 divided by 1. Okay. And that is 1,560 divided by 1, which is 1,560. And this is our final answer. So this concludes our unit on arithmetic property. In our next lesson, we're going to start a new unit. So feel free to rework out any of these challenge problems. Get yourself familiarized and fluent in using any of these properties. Okay, we'll see you next time.